In today's video, we're going to look at the perimeters and areas of similar figures. After this lesson, you should understand the relationship between perimeters of similar figures and the relationship between areas of similar figures, and then we'll use that relationship to find perimeters and areas for similar figures. Before we get started in our notes, I wanted to give you an example of two different polygons looking at their side ratio and their perimeter ratio. Remember, in similar polygons, the angles are congruent to each other, and the sides, corresponding sides, have equal ratios. So side AB to side A1B1 has an equivalent ratio as BC would to B1C1. In this case, we have a ratio of 52 hundredths. Notice also when we're looking at the perimeter, remember, perimeter means that we're adding up all of the sides. That ratio is the same as well. And that will be true for any polygon, and we'll look more at that and use that in order to find perimeters of similar figures. The other ratio that we're going to look at today is side ratio to area ratio. Remember, in, say, a basic rectangle, finding the area is length times width. Obviously, here in our pentagon, the area ratio would be different, but still you're multiplying two different units of measure, and so it's going to be feet squared, inches squared, whatever type of unit of measure that you are using here. So our side ratio is 38 hundredths, and our area ratios to polygon 1, sorry, there's no y there, and polygon 2 is 14 hundredths. Now if I take that side ratio and I square it, I get that 14 hundredths. For both of these properties, it doesn't matter the size of the polygon, so I could play around with this, make one of them bigger, one of them smaller. These properties hold true, and we will use these to help us find perimeter and ratio of similar figures. Now let's take what we have learned and put it into our notes. Since you don't have any fill in the blanks to do, why don't you underline the important information? So it says the ratio of the perimeter is equal to the ratio of the sides. Ratio of the perimeter is equal to the ratio of the sides. Now, what that means is, again, I can take any one of those sides, and it's going to be the same as the perimeter. So it doesn't matter which of those three ratio sides, corresponding sides that I do. In this case, I looked at those two. That would give me the perimeter ratio as well. So a very basic example here, if I want to find the ratio red to blue of the perimeters of the similar trapezoids, all I need to do is find the ratio of the sides, and I know that the perimeter ratio would be equal. So in this case, the red side length that I know is 21. The corresponding side length to the blue one is 15, and it would equal, when I reduce that, so dividing both of them by 3, I would get 7 over 15. So my perimeter ratio is 7 over 5, and that would help me find the perimeter of one of the figures if I needed to. Now the areas of similar figures, like we saw in that little investigation, when two figures are similar, the ratio of their areas is equal to the square of the ratio of the corresponding side lengths. So again, you're going to find a corresponding side length ratio, and this time you're going to square it in order to get the area of the two similar figures, the ratio for that. So in this case, in example number 1, it says find the ratio, again red to blue, of the areas of the similar figures. So if I want to find out the area ratio, I need to first find the side length ratio, which is 9 over 6, and then I need to square it. I would recommend in this fraction, I noticed that I can reduce that, so I would reduce it before I square it, just so my numbers are a little bit easier to deal with, but you could also reduce it at the end. So my area ratio is 9 to 4. So in this case, what this means, this ratio 9 to 4, that means that the red one is bigger in a 9 to 4 units. So maybe one area is 18 and the other area is 8 units. It'll have that it can reduce down to that ratio no matter what the sides are in order to get that area. So the real reason why we are noticing or using these properties is to help us find perimeter and area of similar figures. So we know that those properties are true. We don't want to just state them, even though that is important to know them. We want to use it in order to find missing information. So first of all, I'm going to find the perimeter. And I'm going to look at what I'm given. So it says the width of the pool is 22 yards, which I look right here. Here's my pool, and the width is 22 yards. And I'm also given that this is a tennis court, maybe, that width is 10 yards. So those would be similar figures, and that means that those are corresponding sides. I know the area and the perimeter of the tennis courts, so I can use those ratios in order to find the area and the perimeter of the swimming pool. So if I want to find out the perimeter here, it doesn't matter if I go from swimming pool to tennis court or vice versa. I just look at that side ratio, so 22 for the pool to 10 of the tennis courts, and that, remember, that ratio equals the perimeter ratio. So I don't know the perimeter of the pool, but I do know the perimeter of the tennis court is 60 yards. Now I can solve and find out what my perimeter is. So remember, there are two different ways that I can do this. I could see a relationship between the 10 and the 60 and use that same relationship in order to get the perimeter, or I can find that or make that common denominator by just multiplying by each other. So I'm going to multiply top and bottom by 10 and top and bottom by 60 over here. And so I'm going to get 10p equals, and then I'd put that into my calculator, 60 times 22, and get 1,320. Solving for p, I would need to divide by 10, and I get that my perimeter is 132, and I'm looking at my information here, and it's talking about yards. Perimeter is adding up all of the sides, so it's going to stay yards. So the perimeter of my pool is 132 yards. Now I'd want to move on and also find out the area of the pool as well. So it's going to start out very similar in that I want to set up my ratio 22 over 10, same corresponding sides. Again, it doesn't matter if we go the other way, but this time I need to remember that I need to square this in order for it to equal my area. So the area is going to be over, and if I look over to the side, it says the area is 200 yards for my tennis court there. So again, I have to square this ratio when I'm doing area, whereas perimeter I do not. So I just plug that into my calculator, 22 squared. Remember, 22 squared is just 22 times 22. And so I'm going to get 484. And 10 squared is just 10 times 10, so that's 100. Again, I could see the relationship between 100 and 200 and follow that same relationship to get A, or I can find that common denominator by multiplying by each other. And that gives me 96,800 equals 100A. So then I'll divide by 100. And I get my area is 968. This time, since we're talking about area is width times width, or length times width. So we're going to have yards squared. Don't forget to do your summary and your question. If you have any questions from the video, you may add that into your summary as well.